You guys must have solved a lot of questions from the topic functions. And by now you must have understood how to classify whether a function is a one-one function or not. But this question that you have on the screen is a tricky question, and I've taken this particular question from the All India test series of the famous coaching institute FIITJEE. So let us go and solve this particular question. You'll get to learn a lot of things from this video. So make sure you watch till the end. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT-JEE. Before we go through the solution, so let us say if you have a function and if you can draw the graph of the function, from the graph you can perform horizontal test and can conclude whether that function is injective function or not. So to classify or to conclude whether a function is injective function or not, you have to draw the graph of the function. All right. So, but in this case, the function which is given to you has got algebraic terms and the trigonometric terms. So drawing the graph for this function is little tricky and it is complex as well. So how do you proceed with these kind of questions? And also, this is not a straightforward question where you will be given a function and asked to comment whether it is an injective function or not. In this question, it is already given that this given function is injective and you have to, and your task is to find out the value of a for which this function becomes injective function. All right. So before going through the solution, I would like to explain few concepts about functions. So I have made a chart for you guys here. So let us go through it one by one. So let us say your function has a local minima. Then your horizontal test fails. All right. So two values on the x-axis gets mapped to the same value on the y-axis. So your horizontal test fails. So if a function has a minima, then it is not a one-one function. Similarly, if a function has a local maxima, even in that case your horizontal test fails. Therefore, if a function has a local maxima, even then your horizontal test fails and that will not be a one-one function. All right. So the next case is, let us say your function is continuously increasing. Then your horizontal test passes at all the points. All right. All the points on the function. So even in the case when your function is constantly decreasing, something like this, even in that case your horizontal test passes all the time. So from this particular discussion, you can conclude that all monotonically increasing functions and decreasing functions are one-one functions, and the functions which has local maxima will never be a one-one function, and similarly the functions which has local minima will never be a one-one function. Now, how do you check whether a function is monotonically increasing or monotonically decreasing? So let us say you have f of x. All right. Then three things can happen. When you find the derivative might be 0, it can be less than 0, or it can be greater than 0. If it is greater than 0 for all the values of x, this is not at any specific value. If it is greater than 0 for all the values of x in the domain, then the function is said to be monotonically increasing. If the derivative is less than 0 for all the values of x in the domain, then the function is said to be monotonically decreasing. If the derivative is equals to 0 at any specific point, at that point we can have three scenarios. The first thing is the double derivative can be 0, or double derivative can be less, or double derivative can be less than 0, or double derivative can be greater than 0. So when the first derivative is equals to 0 at any specific point of a function, so then we will have these three cases for the second derivative. When second derivative is less than 0, at that particular point we will say it has a local maxima. The function has a local maxima at that particular point. And when second derivative is greater than 0, we will say the function has local minima at that particular point. And when the second derivative is equals to 0, we have to go further. We have to go to the third derivative. So find out the third derivative at the same point. If the third derivative is not equal to 0, then it is an inflection point. If the third derivative is equals to 0, then it can be local maxima, local minima, or inflection point. We have to go ahead to the fourth derivative, fifth derivative and analyze whether it is a local maxima, minima, or inflection point in this case. If you want to understand that particular thing, if you want to know how this analysis is done, go to the comment section and comment higher derivative analysis. So this is the funda that we have. All right. Now let us go ahead with the question. So you have f of x here. So your f of x is x cube plus x square plus a cos x. Now let us find out f dash of x. F dash of x is 3x square plus 2x minus a sine x. Alright. Now you cannot conclude whether f dash of x is greater than 0 or less than 0 from this particular thing, because you have a parameter here and you don't know what that parameter is. So what can you conclude from this expression? Pause the video for a minute and come up with an idea. What can you conclude from this particular expression? It can be concluded that x is equal to 0, f dash of x becomes 0. F dash of 0 is equal to 0. Put 0 in the place of x, it becomes 0. So at a specific point, which is x is equal to 0, in this case, we got f dash of 0 is equal to 0. Now let us go ahead and find the second derivative. So your second derivative will be f double dash of x is equals to 6x plus 2 minus a cos x. So at 0, since we are performing the analysis at x is equal to 0, f double dash of 0 is simply 2 minus a. Now if f double dash of 0, which is 2 minus a, if this particular quantity is negative, then we will have local maxima. If you have a local maxima, the function will not be injective. If this is greater than 0, you'll have local minima. If local minima exists, the function will not be injective. So this has to be 0. So f double dash of 0 is equals to 0. So then you'll get a is equals to 2. Now we have already discussed that if f double dash of x is 0, we have to go and check the third derivative. So let us go and check the third derivative. F triple dash of x is 6 minus 6 plus a sine x. Alright. Now at x is equal to 0, f triple dash of 0 is simply 6, which is a non-zero value. Therefore, it is an inflection point. So it is not a local maxima or local minima. So we have concluded that at third derivative is also not equal to 0. So therefore, only when third derivative is not equal to 0, this is an inflection point. Inflection point is where the concavity changes, something like this. So let us say this is the graph of y is equal to x cube. So till here, the graph is concave downwards, and after that the graph became concave upwards, but it is strictly increasing. So therefore, we can conclude that value of a is 2. I hope you all got something to learn from this particular video. So I have tried explaining all the concepts of calculus that you can use to conclude whether a function is an injective function or not. So if you need any further clarifications on the method that I have given, or if you want to understand the higher derivative analysis, do go to the comment section and comment higher derivative analysis. I will make a new video on it. So if you want to know more examples, I mean examples of the functions for which this happens, if the third derivative also becomes 0, and you want to know how to like determine whether a specific point is a local maxima, local minima, inflection point, all of that, I can bring some good examples to you and make a video on it. So do go to the comment section and write it out there. Also, if you have any queries about this particular question that I've explained, so let me know in the comment section. I'll be happy to clarify your doubts. And I've recently uploaded a very wonderful video where you will have to find out the number of real roots of a 16th degree polynomial, which the coefficients of this 16th degree polynomial looks really huge and nasty. So if you are interested, do check it out. You will get to learn a beautiful technique or method which is important for JEE as well. So do check out, the video is there in the end screens. And if you like the content that I'm making, share it with your friends, subscribe and leave a like. Let's meet in the next video.